Okay, so in the previous class, we have already discussed how to convert any base to decimal number. So as for example, if you are going to convert 111, 110, if this one is a base 2, what is the decimal number? Anyone? How to find? We have to start the numbering from here. So 0, 1 and 2, minus 1, minus 2 and minus 3. How to write? 2 means 4 plus 2 plus 1 plus 1 by 2 plus 1 by 4. What is the value it will come? 4 plus 2 plus 1, 7. Point. What is the value of 1 by 2? 0 0.5 plus 0 0.25. So 7.75. Okay. Clear? So anyone, any doubt in this concept? How we are going to convert any base to decimal number? Now we'll try one more. Okay. So now we'll check for this one. Something called 757.17 base 7. What is the decimal value? Anyone? What is the decimal value? Yes, right. So this is an invalid number. Why this is an invalid number? Because if the base is 7, we cannot write 7 in a single place. Maximum we can write 6. Okay. So here you can write like that. This is your base 8. Now we'll find, and then we will find one more case. A 5 B base 16. What is the decimal number? Okay, what is the decimal number? If you are writing A is B base 16, what is the decimal number? Anyone? What is the decimal number if you are writing A is B base 16? A means this is a base 16, so after 10, 10 means you will write A, 11 means you will write B, 12 means you can write C, 13 means you can write D, 14 means you can write E, and 15 means you can write F. Okay, so if you are writing the number in terms of hexadecimal, then in this case you will also get the term called A, B, C, D, E, or F. You will also get the term called A, B, C, D, F. Okay, so now first one we will try what is the value we can write. So you can simply write 8 to the power 2 plus 5 into 8 plus 7 plus 1 by 8 plus 7 by 64. This is the value for first expression. Same like that, if you are going for the second expression, what value will write? 0, 1 and 2 in the 0th place, 12 is present, means B means 11. So we'll write 11 into 16 to the power 0 plus 5 into 16 to the power 1 plus A means again we'll write 10 into 16 to the power. This is the value we will calculate. Okay. So this is a normal procedure that is used to convert any base to the decimal number. And why we are converting any base to the decimal number? Because we are very much familiar with the decimal number. In the real life, we are only using the decimal number. We are not using the other base. But if you are talking about the computer point of view, then we are only using the binary number. Sometimes we are also representing the octal number, and sometimes we are also representing the hexadecimal number. Binary number means the base is 2. Octal number means the base is 8, and hexadecimal number means the base is 16. Okay, so only the 3 types of representation we are using in the computer system. First one is called the binary number, second one is called the octal number, and third one is called the hexadecimal number. Third one is called the hexadecimal number, and this is your most important one. If you are getting any number starting with 0, if you are writing 0 to 5, that will consider as a octal number. That will consider as a octal number. If you are writing 0B, whatever the number you are writing, that will consider as a binary number. If you are writing 0x576, that will consider as a hexadecimal number. That will consider as a hexadecimal number. So as for example, here you can see what I am saying. So now you can see. I'm going to open this file. Okay. So on the desktop, okay. So we are writing here has include okay, and here we are writing the simple one term called in A equal to 0, 5, 6. Can you tell me what value it will print? Anyone? What value it will print? If you are going to print this value of A, what value it will print? Okay, if you are writing int A equal to 056, means basically you have written the number in octal format. And if you are going to execute, just you will see what value it is printing. It is printing the value 46. Can you tell me what is the decimal representation of 056? What is the decimal representation of 056? 46. Okay, so you have to check the question carefully. If you are going to appear for the placement exam, if you are going to appear for the gate exam, first you have to check the number system. This is not like 56. If you are writing int a equal to 056, this is not a 56. This is actually 46. So sometime it will be given like that, a equal to a plus 10. After that you are adding 10 to a. What value will come? A equal to a plus 10, 46, or a equal to a plus 12 if you are writing. What is the answer you will get? Initially, what is the value of a? 46. Then you are adding 12 to the 46, you are getting 58. So if you are going to check here, it will come 58. Clear? It will come 58. So same like that, if you are writing in the terms of binary, you will write 0b, a small 0, and then you will write a small b, 0b. Okay, same like that, if you are writing the hexadecimal, you will write 0x, that is your hexadecimal. Okay. Okay, and most of the time you will get the confusion when you are getting the number 0 to 5, and most of the students are thinking like this here 25, but this is not a 25. This one becoming a 8 into 2 plus 5, 21. Clear? 21. Okay. Now we'll see how to convert decimal to any base. If the number is given in the decimal format, how to convert this decimal to any base? How to convert this decimal to any base? Okay. Clear? How to convert this decimal to any base? Okay. So as for example, we are writing the number equal to 56. And if we are going to convert this 56, that base is 10 to, the base is your, or any base you are going to convert to the x. Now we'll see how to convert 56 to base 2. So if you are going to convert the 56 decimal to binary number, first you have to take 56 and then you will divide by 2. Okay, whatever the base you are taking, you have to divide it by 2. If you are going to divide 56 by 2, what is the remainder value will get? What is the remainder and what is the quotient value will get? Anyway, what is the remainder value will get? Remainder value will get, if you are going to divide 0 and the quotient is 28, so we will write 28. Same like that, if you are going to write 2 again, you have to divide it by 2 again. You have to continue this process until you are getting the quotient value equal to 0. Okay, so again we are writing 12. What value will get? 40. 0. Again we are writing 12. We are getting 7. 0. Again we are writing 2. So what value will get? You will get 3. 1. Again we are writing 2. You are getting here values. You are getting here values 1. 1. Okay. Either you can stop here. If you are getting the value, the quotient value is less than your base value, then we can stop. If you are going to write this quotient value in this base format, then we can stop. And after that, we have to write in the reverse manner. Okay, we have to write in the reverse manner. So we will write 1 1 1 0 0 0, something like that. 1 1 1 0 0. Now you have to check whether this is right or wrong. 0 1 2 3 4 5. How to check? 5 means 2 to the power 5 plus 2 to the power 4 plus 2 to the power 3. Can you tell me what is the value will get? Anyone? 2 to the power 5, 32 plus 16 plus 8. What is the value will get? 56. Okay. Now you can see the procedure again. I am going to explain. Okay. Now we are going to convert 76 or 75. Okay. What is the procedure? First we will divide it with 2. Okay. What is the quotient value if you are going to divide 75 with 2? Anyone? What is the quotient value? Anyone? 37. What is the remainder? We have to write 1. Again, we will divide by this one. What is the quotient value we'll get? 18. Remainder. Again, we will divide it by 2. What is the quotient value? 9. Remainder 0. Again, we will divide it by 2. Then we will get 4. 1. Again, we will divide it by 2 because we cannot write 4 in base 2. So we are getting here 2, 0. Again, we will divide it by 2. We are getting here 1, 0. Now we can write 1 in base. This base we will write in the reverse order. 1 0 0 1 0 1 1 0 0 1 0 1. Okay, so 1 0 0 1 0 1 1 1 0 0 1 0 1. Now we have to check whether this is working fine. So 0 1 2 3 4 5 and 6. What is the value we'll get here? Anyone? Can you tell what is the value we'll get? What is the value we'll get? Just will tell me what is the value we'll get here. 75. How we are going to calculate? 2 to the power 6, 64 plus 8 plus 2 plus 1. Now we calculate the value. We are getting 75. Okay, we are getting 75. Same like that, if we are going to check, just we'll see if we are going to convert. This is the base 75 with base 4. Can you tell me what is the value we get? If we are going to convert 75 base 10 with something base 4, what is the value we get? What is the value we'll get? Just we'll try what is the value we'll get. Just tell me what is the value we'll get. Okay, so some students have already calculated 1023. So now I am going to check whether you are getting the right answer or not. 1023 base 4. So 0, 1, 2, 3. So you are getting 4 to the power 3 plus 4 to the power 2 into 2 plus 3. What is the value we get? 4 to the power 3. What is the value we get? 4 to the power 3. 64 plus 4 to the power 1. You are getting 0 and 1. So 4 to the power 1. So 4 into 2, 8 plus 3. What value will get? 64 plus 8, 72 plus 3, 75. So this one is your right answer. Clear? This one is your right answer. Now we'll see what types of question you can expect in your exam related to the number system. Okay. So as for example, first you can see one question given in this question. Okay. What is given like that? So consider the equation 1, 2, 3 base 5 equal to x8 base y. 1, 2, 3, 1, 2, 3 base 5 equal to x8 base y. Here x8 base y. Now you can see I have already x8 base y. Now we have to find what are the possible solution of x and y, or what are the possible value of x and y. Anyone can tell me how to solve these types of problem? So it is clearly mentioned like that. If you are 1, 2, 3 base 5 equal to you are getting x8 base y, what is the possible value of x and y? Anyone? Okay, so first can we write here whatever the value of y you are getting? Yes, first we will convert this one both to the decimal value. But before we have to write what is the possible value. So can we write the value of y must be greater than 8? Can we write? Can we write the value of y must be not greater than equal to 9 you can write, or greater than 9 can we write? The value of y must be greater than equal to 9. Can we write? Why we are writing the value of y must be greater than equal to 9? Why we are writing? Because here we have written 8, and if you are writing the 8, definitely the base must be greater than 8. So either you can take 9, 10, 11, something like that. Okay. So whatever the solution you have given, x equal to 3, y equal to 1, that is not the right solution. That is not the right solution. Second one, the value of x must be smaller than y. Second one, the value of x must be smaller than y. Now you can see, if we are going to convert this one to the decimal number, what is the value we will get? Anyone. If you are going to convert 1 to 3 base 5 to the decimal number, what is the value we get? Anyone. Can you tell me what is the value we get? If we are going to convert 1 to 3 base 5, we are getting 38. Right? We are getting 38. Okay. Okay, some students are saying like that. So 5 into 2, 25 plus 10 plus 3, 38. 38 equal to, can we write xy plus 8? Can we write xy plus 8? If you are going to convert this one, we will get xy plus 8. Can we write the xy equal to 30? We are getting the value xy equal to 30. Just to write the possible solution where the value of y must be greater than 9. So we will start from 9. Okay, if we are taking 9, we cannot find. If we are writing 9, the value of y equal to 9, can we get the value of x equal to integer? Because here we are always writing the integer, so we cannot take y equal to 9. Now we will take y equal to 10. When you are taking y equal to 10, the value of x is equal to 3. When you are taking y equal to 11, the value of x is not an integer. So second one we will take 15 2, and third one we will take y equal to 31. What are the possible solutions we are getting here? There are 3 solutions will exist. Okay. So first one, y equal to 10, 3. Second one, y equal to 15 and x equal to 2. And third one, 30 and x equal to 1. So total number of solution, if someone will ask what is the total number of solution, the total number of solution equal to 3. Total number of solution equal to 3. Okay. Now at least you will try this question. This one. Okay. Yeah, this question. To find the value of x, not the each, find the value of x in decimal number. Okay. So how to solve these types of problems? So first one you can see, it is clearly written 15y minus 41y equal to 6y. Okay. So 50y, we are writing 50y minus 41y equal to 6y. Okay. If you are going to convert to the decimal number, what is the value you write? 5y minus 4y minus 1 equal to 6. If you are going to write y equal to, what is the value? 5y minus 4y, y equal to, we are getting here 7. Okay. So y equal to, we are getting here 7. If you are getting 7, now you have to put in the second expression and you will get the value of x. You will get the value of x if you are going to put in the second expression. So 55y minus 36y. So what is the value of 55y?
So that should be 6y, right? Oh, no.
Okay. So what is the value? We will write 55y. Just you can see it is written like the same. So 55y. Okay. So base is already we have calculated 7. So if the base is 7, what is the value of 55? What is the value of 55 in decimal? If the base is 7, anyone. What is the value? We are getting 35 plus 5, 40 minus, if we are going to write 36, so we are getting 7 into 3 plus 6. What is the value we are getting? 40 minus 7, 21 plus 6, 27. So we are getting here value. What value we are getting? Now this is 55. So we are getting here value 13, not the 16. We are getting the value equal to 13 in base number. What base we are getting? 13. 13 in base 10. If you are going to write 13 in base 7, how to write 13 in base 7? Then we have to write 16 base 7. That is equal to 13 base 10. Clear? That is equal to 13 base 10. Okay. Okay. So now we'll go one more. Okay, that we'll see. Okay.
Sir, so the final answer is 13, right?
Yes, final answer is 13. Okay, clear? Okay, now we'll see about the how to convert point wise. Okay, so if you are getting something called 15.25, okay, 15.25, and if you are going to convert this one to some binary number base, how to convert? Okay, so here we are getting 15, and after that we are getting dot, and then we are getting 25, and we are going to convert this decimal value to binary value. What is the procedure? First, we will convert to the 15. How to convert 15? You already know the formula, or you already know the procedure. We will divide it by 2. We are getting here 7. Okay, 7, remainder is 1. Again divided by 2, 3, remainder is 1. Again divided by 2, 1, 1. So we are getting 1, 1, 1, 1. This is the 15. Okay. After that, you write dot. After dot, whatever the value you are getting, we are getting 0.25. Now, before the dot, you have to divide, but after dot, you have to multiply. Okay, multiply with the base 2. What is the value we are getting here? 0.5. Okay, if you are going to write 0.25 into 2, what value will get? 0.5. What is the value present here? You have to write here. And after that, what is the value present here? You have to write here. 0.5 into 2, you are getting 1.0. 1.0. What is the value 1 here? You will write 1 here. And after that, we are getting 0. If we are getting 0, then we will stop here. We will stop here and this value become 4101. If you are going to convert to the decimal number, how to convert? 0, 1, 2, 3, and this one minus 1, minus 2. What is the value we'll get here? This is 15 plus 1 by 2 into 0 plus 1 by 4 into 1. What value will get? 15.5. Now again we'll try. Just you can see what I'm writing here. 15.625. Okay, 15.625 base 2. Base 10, you are going to convert to the base number. How to convert? First, we will convert to the 50. You already know the procedure. We are getting 1, 1, 1, 1. This is 50. If you are going to convert after decimal number, what we have to write? 0.625 into 2. What value will get? Anyone? 0.625 into 2. What value will get? Anyone? You will write here down. What value will get? 0.625 into 2. Anyone? 0.125 or 1.125? 1.25. If you are getting 1.25, this is 1, we have to write 1 here. And after removing 1, what value we are getting? 0.25. 0.25 into 2, what value will get? 0.5. Again, we are getting 0. We will write 0 here. Again, 0.5. 0.5 into 2, we are getting here. What value we are getting? 1.0. Again, we will write 1. And after that, when we are getting 0.0, we will stop here. Okay, now you have to solve. Just we check whether you are getting the same value or you are getting the different value. So this is your 15 plus 1 by 2 plus 1 by 8. Now we'll find what is the value we'll get. Anyone? 15 plus 1 by 2, 0.5 plus 1 by 2, 0.125. What is the value we are getting? 15.625. Clear? 15.625. Okay, now last one I'm going to give you. 15.2 base 10. If you are going to convert to the binary value, how to write? Only one. 15.2 base 10.
Sir,
Yeah.
sir, wouldn't we get recurring value in this?
Yes, just to try. Just to try. So what value will get for 15? We have already calculated 1, 1, 1, 1. And if you are going for 2, so 2 into 2, what value will write? 0.4. So we are writing here. Then 0.4 into 2, we are getting 0.6. We are writing again 0.6 into 2, we are getting 1.2. We are writing 1. And again, we are getting 0.2 into 2, we are getting again 0.2.
Sir,
If we are getting
0.4 into 2 is 0.8.
Oh, sorry. Yeah, just one second. There is some mistake. Yes, 0.2 into 2, we are getting 0.4. Okay, so we are writing here 0.4 into 2, we are getting 0.8. Okay, so we are writing 0.8 into 2, we are getting 1.6. So we are writing 1. Then 0.6 into 2, we are getting 1.2. Again, we are writing 1. Then 0.2 into 2, again, we are getting the same pattern, right? Again, we are getting the same pattern. If we are getting the same pattern, then we will stop here. If we are getting the same pattern, then we will stop here and we will get the answer equal to 111100. Now, can you tell me what is the decimal value? What is the decimal value? Anyone, what is the decimal value? Anyone, what is the decimal value? If you have written this is a binary format, just tell me what is the decimal value? Anyone, what is the decimal value if you are writing 41.00? So this one you already know 15 point. This value will write what? 15 plus 1 by 2 we cannot write, 1 by 4 we cannot write, 1 by 8 plus 1 by 60. What value we are getting? 15.1875. Okay. Now I am going to ask you one simple question. Can you tell me what is the value of 1 by 2? Anyway, what is the value of 1 by 2? 1 by 2. Okay. Yeah. And what is the value of 1 by 3? 1 by 3. What is the value of 1 by 3? 1 by 3. Okay. Now you can see the answer. Just you can see the answer. If I am asking the question 1 by 2, all the students are giving the answer 0.5. But when we are asking the 1 by 3, some students are saying 0.33. Some students are saying 0.33. Some students are saying 0.333. Some students are saying 0.334. Something like that. Why we are getting the different answer in case of 1 by 3? Why we are getting the different answer? Can we say we cannot find the exact value in decimal if we are writing 1 by 3? Can we say we cannot find the exact value in a decimal if we are writing 1 by 3? Okay. Now you can see this is very, very important part. Very, very important part. Just you can see. Okay. Just you can see. This is very, very important part. Okay. Now you can see. I'm going to open a.c. Now you can see the magic here. Okay. Now you can see. If I am going to write here float, float means you are going to represent the real number. Float a equal to, I am writing here something called 2.5. Float equal to 2.5. And then we are writing if. If means basically the condition. That will see more detail what to mean by if. If a equal to 2.5, printf, okay, else printf Hyderabad. Okay. It means basically we are going to check the value. If the value of a equal to 2.5, it will print bit. Otherwise, it will print. Now I am going to execute this expression. What value it will print? It will print bits. If I am going to write here 2.2, can you tell me what the value it will print? If I am writing float a equal to 2.2, and if a double equal to 2.2, print a bits, and otherwise it will print Hyderabad. Now you can see. It is printing Hyderabad. Can you tell me why it is printing Hyderabad? If you are writing float a equal to 2.5, it is printing bits. And if you are writing float a equal to 2.2, it will consider as a false statement. The logic is very simple. Now you can see I am going to write 1 by 3 equal to 1 by 3. Now assume that one student is calculating this value and second student is calculating this value. Can you confirm that both the values are same? Can you confirm that both the values are same? No. But when you are calculating 1 by 2 double equal to 1 by 2, can you confirm that both the values are same? Can you confirm that both? Yes, definitely. Because here you are getting the exact value. The same procedure we are going to follow here. If you are going to convert, because we already know computer can only understand the binary value. If you are writing any decimal value here, 2.5, first it will convert to the binary value. And if you are getting the exact binary value, then this statement consider as a true statement. But if you are not getting the exact binary value, then this statement is considered as a false statement. So as for example, here again you will see 2.625. If you are writing 2.625, and again we are writing here 2.625, just you can see again it will print the bits value. Again it will print the bits value. Just you can see why it is printing the bits value, because we are getting the exact binary representation for 2.625. We are getting the exact binary, but when you are writing 2.6, we are not getting the exact binary representation of this value. That's why it is printing the Hyderabad. Okay, so for this types of questions are coming, first you have to check whether you will get the exact binary value of this floating point representation or not. And if you are not getting the exact binary value, then in this case you always execute the else part. You will not execute the true part. We will not execute the true part. Clear? So anyone, any doubt how it is printing Hyderabad when we are writing 6 to 5? Why it is printing bits? And when we are writing 2.6, why it is printing Hyderabad? Clear? Any doubt? Okay. Clear.
Sir,
Yes.
sir, if we are using whole numbers as base like 2, 3, 4, and 5, we are getting some numbers to be terminating, some numbers to be recurring.
What
I mean,
you are getting?
no,
Just
sir. If
write
we,
in the chat box. Whatever the question, please write in the chat box.
Okay, sir.
That we will discuss. Please write in the chat. Okay, clear? Okay, so do we enter a range to get the output as a bits in? No, we cannot. Just you can see this one. The system is going to store. Okay, so what will happen like that? System is going to store 2.2. Okay, when the system is going to store, means it will always store in the terms of binary number. Okay, it will not store the 2.2. Okay, so now you can see the system is already stored the value this year 2.2 in the binary number. We are not getting the exact binary number, so it will store the approximate. Okay, and when we are going to execute the program, the compiler will check whether the value, whatever the value is present here, that is equal to 2.2 or not. Compiler will use their own method to convert this 2.2 to binary number. Now, in this case, what will happen like that? This number will not come as a same. You are going to get like the same thing 0.333, and someone will write 0.334 or 0.3334 time it will write. So in this case, we can see this number are not same. But when we are writing 1 by 2 double equal to 1 by 2, and if you are asking the two different students, definitely both will say like that 0.5, 0.5. Okay, because we are getting the exact decimal. Okay. I have already mentioned. Just will focus on the concept. Focus on the concept. What I am writing, just will see. If I am writing 2.4, and if you are writing a number a equal to 2.4, can we say this statement is true statement? Anyone? Can we say this statement is true statement? No. Why this statement is not a true statement? Blindly we cannot say. Just you can see. 0.4 into 2, what will get? 0.8. 0.8 into 2, we are getting 1.6. 0.6 into 2, we are getting 1.2, then 0.2 into 2, we are getting 0.4. Again, we are getting the same number. If we are getting this type of pattern, then in this case, we can say this is a false statement. But when we are writing a equal to 2.25, can we say this is a right statement? Yeah, this statement is true. I am talking about this is a logical operator. It will only return 1 or 0. It will only return 1 or 0. If this expression is true, it will return 1, and if this expression is false, it will return 0. So in this case, it will consider as a false statement. It will consider a false statement because it's a logical operator. That will see more detail during the logical operator. When we will discuss about the operators, that time we will see more detail regarding that. Okay. Now the same like that, if you are writing 2.25, we will check like that. In the case of 2.25, we are getting the exact binary. Okay. Now we are coming to the most important part, that is called the signed number. That is also called the signed number. Okay, signed number. Signed number means whatever we have discussed, that is only for the positive number. But when we are going to write some negative number, if you are writing -5, if you are writing -7, if you are writing -13.5, how the system will store -13.5? How the system will store -5? How the system will store -7? Something like that. For the positive number, you already know. So there are two types of number. One is called the unsigned number, and second one is called the signed number. Unsigned number means it will only use to store positive number. It is only used to store positive number. But the signed number, it is used to store both positive as well as negative number. It is also used to store positive as well as negative number. So what is the difference between unsigned and signed number? Unsigned number means it will only store positive number, and signed number means it will store both positive as well as negative number. Okay. Now, if you are taking the unsigned number, okay, and if you are taking only 2 bits number, what is the minimum value we can store? We can write this types of pattern. These are the possible value we can write: 1, 0, and 1, 1. What is the minimum value we are storing here? 0. And what is the maximum value we are storing here? 3. Okay. Means if the number of bit equal to 2, we are storing the minimum equal to 0, and maximum we are storing 2 to the power 2. Same like that in the unsigned number, if the number of bit equal to n, we can store minimum 0, and maximum we can store 2 to the power n minus 1. Clear? Up to here, anyone, any doubt? That we have already discussed in the previous one. Any doubt here? Any doubt? In the case of assigned number, why we are writing 0 to 2 to the power n minus 1? Any doubt? Okay. Now we'll come to the main important point, that is called the signed number. Okay. So there are three different ways to represent the signed number. One is called the signed magnitude number. Second one is called the 1s complement, and third one is called the 2s complement. Okay. And nowadays we are only using the 2s complement. We are not using the 1s complement, and we are not using the signed number or signed magnitude number. Okay. But previously we are only using the signed magnitude number. After that, the researcher had proposed the 1s complement, and after that the researcher had proposed the 2s complement, and nowadays we are only using the 2s complement. Now we'll see what is the benefit of using 2s complement over 1s complement and signed magnitude number. But before that, first we'll see how to represent any number using the signed magnitude number, using the signed magnitude number. So we have already discussed there are three different ways to represent. The slide I have already put here. So unsigned number you already know. Unsigned number means only the positive number, and signed number means signed magnitude representation. 1s complement and 2s. Now you can see this is the very, very important part. Okay. Now you can see in the signed number, first we are taking the 2 bits number. Okay. First we are taking the 2 bits number. So what the possible combination there are 0 0 0 1 1 0 1. Then we are taking 3 bits number. What are the possible, how many combinations we can write? 8 different combinations. 1 1 1 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0. If we are taking 4 bits, that is sufficient. 4 5 6 7 8 2 3 4 5 6 7, and we are also writing. Okay, so we are writing. Okay, now we are writing. Clear? So these are the combination we can write if we are taking the 4 bits number, if we are taking 3 bits number, and if we are taking 2 bits. Okay. According to the sign magnitude representation, in the case of sign magnitude representation, the first bit basically used to represent the sign. Okay. Whatever the first bit you are writing, that is used to represent sign. If the first bit equal to 0 means you are writing the positive number, and if the first bit equal to 1 means you are writing something called negative number. Okay, first bit equal to 0 means you are writing positive number, and first bit equal to 1 means you are writing negative number, right? Okay, now you can see. So first one, what we can write? If we are writing 0, first one your 0 means number is positive. What is the decimal value of this 0? Plus 0. First one, number is positive. 1 means what is the decimal number of 1? We are getting here 1. This one is 0 means first bit negative minus 0, and here if you are writing 1 means what we can write? Minus 1. Same like that. You will check. First bit 0 plus 0. Second bit 0 0 1. What value will write? Anyone? What value will write? 0 0 1. First one is your positive. What is the decimal value of 0 1? Decimal value of 0 1 1. So we are writing here positive 1. Second one 0 1 0 positive 2. Third one 0 1 1 positive 3. 1 0 0. Tell me 1 0 0. What value will write? What will we write? Minus 0. What value will write? 1 0 1. Minus 1. 1 1 0. Minus 2. Minus 3. Same like that. Here we will write 0 1 2 3 4 5 6 7. Okay. Then we are writing here minus 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Clear? Minus 7. Now here you can see, if you are taking 2-bit number and if you are taking the sign magnitude number, okay, can you tell me what are the distinct number we are writing? What are the different number we are writing? Anyone? What are the total number of different numbers we are writing? Can we say is there any difference between plus 0 and minus 0? Can we say is there any difference? No, there is no any difference between plus 0 and minus 0. So here, what are the total distinct number we are writing? 1 is 0, 1 and minus 1. What is the total? 3. In this case, what is the total number we are writing? 7. And in this case, what is the total number we are writing? 50. Okay, just you can see. If we are going to the previous case, only the unsigned number, what is the total number of distinct number we are writing? 2 to the power n. But in this case, we are writing 2 to the power n minus 1. Okay, so the total number of distinct number equal to 2 to the power n minus 1. What is the minimum number we are writing? Anyone? What is the minimum? If the bits equal to this one, 2 bits, can we write? We are writing the minimum equal to minus 2 to the power 2 minus 1. Same like that, here we can write minimum equal to this one minus 1. We can write minus 2 to the power 3, means 3 minus 1 minus 1. And here you write minus 2 to the power 4 minus 1 minus 1. Can we write? What is the value of minus 2 to the power 4 minus 1? If you are writing this expression, what is the value we write? What is the value we are getting here? Just wait. Okay. Now you can see what value we will write here. Can we write this value equal to minus 1, this value equal to minus 3, and this value equal to minus 7. Okay. Now you can see if we are taking, this is very, very important. If you are taking sign magnitude representation of the number, you can write maximum 2 to the power n minus 1 number with n bits, and you can write a minimum minus 2 to the power n minus 1 minus 1 to 2 to the power n minus 1 minus 1. This is the range of the number. As for example, if the number of bits equal to 10, can you tell me what is the minimum value we can write in the case of sign magnitude representation, and what is the maximum value we can write in the case of sign magnitude number? If the number of bits equal to 10 bits, anyway, can you please write? What is the minimum number we can write if the number of bits equal to 10 bits? What is the minimum we can write, and what is the maximum we can write? Anyone? What is the minimum we can write? Minimum minus 2 to the power 10 minus 1 minus 1 to 2 to the power 10 minus 1 minus 1. What is the value to become? Minus 511 to 511. We can write minus 511 to 511. Okay. But what is the disadvantage of this sign magnitude number? Anyone can you tell me what is the disadvantage? Can we say the one disadvantage we are getting the two representation of 0. In the real life, either we are saying positive 0 or negative 0, both are same, but here we are getting the two different representation of 0. This is the one disadvantage of using the sign magnitude number. This is one disadvantage of using the sign magnitude number, because we are getting the two different representation of 0. So if you are saying 0, that is not as sufficient. Either we will say positive 0 or negative 0. But in the real life, there is no any difference between positive 0 and negative 0 in the real life. But according to the, yes, just you can see, in the real life, positive 0 equal to negative 0. But according to the sign magnitude representation, positive 0 is not equal to negative 0. According to the sign magnitude representation, positive 0 is not equal to negative 0. This is the one disadvantage here. Okay. Now the second disadvantage, you can see. Can you tell me what is the value of minus 1 minus 2? If you are writing minus 1 minus 2, what is the value we'll get? If you are going to solve this expression, what is the value we'll get? Good. Minus 3. Okay. Now, if you are going to write minus 1 and minus 2 both, what is the minimum number of bits required to write minus 1 minus 2 in the case of sign magnitude number? Anyone? In case of sign magnitude number, what is the minimum number of bits? If you are taking 2 bits, you can only write minus 1 and 2, 1. You cannot write minus 2 if you are taking 2 bits. Can we say 3 bits, minimum 3 bits? Because if you are taking 3 bits, then you can write minus 3, 2 plus, okay, 3 bits, okay, minus 3, 2 plus 3. Now you can see, if you are going to write minus 1 using 3 bits, how to write? First one, minus 1 means sign is equal to 0, and after that we'll write 0, 1. This is minus 1, and minus 2 means we'll write 1, 1, 0. Can we write? Can we write? Just to check. Because in the sign magnitude, the first bit is used to represent the sign, and we are writing minus means first one your 1, and after that we are writing 0, 1, and then in the case of minus 2 we are writing this. Okay. If you are going to add these two numbers, just will tell me what is the addition. We have already discussed in the previous class. 1 plus 0, what value we get? 1 plus 0, 1 plus 0, what value will get? 1. 0 plus 1, what value will get? 1. And 1 plus 1, we are getting 0. And we cannot take the last bit. Why we are not taking? Because our number is only 3 bits. So we can only store 3 bits. We cannot store 4 bits number. We can only store 3 bits. Because minus 3 can be also, minus 3 can be also written by using 4 bits. You can also write. But here we are taking the minimum number of bits. We are taking minimum number of bits. Okay. Now we'll tell you, because we cannot write the 4th number, now we'll tell you what is the value of 0, 1, 1. Anyone? What is the value of 0, 1, 1? 3. Now you can see, according to the real life, if you are writing minus 1, minus 2, you will get minus 3, but you are getting the value equal to 3. Can we say the second disadvantage of this simple matching or the sign magnitude number 8, the normal addition will not. Can we say the normal addition will not work here? Why we are saying the normal addition will not work here? Because we are taking the 3 bits number, and the 3 bits number we can also write this value, but still whatever the answer we are getting, that is not the right answer. That is not the right answer. Can we say that is not the right answer? If we are writing 0, 1, 1, we are getting 3, but actually minus 1, minus 2, we will get the answer equal to minus 3, but we are getting the answer equal to 3. We are getting the answer equal to 3. So can we say here the normal addition will not work? Can we say here the normal addition will not work? Can we say? So this is a two disadvantage of using sign magnitude number. Two disadvantage of using sign magnitude number. So after that, the researcher had proposed one new number that is called the 1s complement of the number. That is called the 1s complement of the number. That is called the 1s complement of the number. That we will see in the next class. That is also very important. 1s complement and 2s complement. And now after that, we will also see why we are using only 2s. Okay, but for the today class only we'll remember the two terms. If you are working for the unsigned number, minimum you can represent 0 and maximum 2 to the power n minus 1. The total number of unique number you can represent 2 to the power n. If you are working for sign magnitude number, you can represent minus 2 to the power n minus 1, 2 to the power n minus 1, minus 1, and total number of unique number 2 to the power n minus 1. Okay. Now, the next one is little bit important. That is also very important. Okay. Now, if you are taking this 4-bit number, this is your bit number 0, 1, 2, 3. If you are talking about the unsigned number, what is the minimum value we can represent? If you are talking about the unsigned number, what is the minimum value we can represent? Anyway, what is the minimum value we can represent if you are taking unsigned number? 0. What is the maximum value we can represent? Maximum value we can represent. What is the maximum value we can represent? 50. But now assume that if you are planning to represent 16, what value it will represent? If you are planning to represent 16, what value it will represent? Because you are using only 4 bits number and you can store maximum 15, but after that you are giving the instruction to store 16. You are giving the instruction to store 16. What value it will return? It will follow this type of clock cycle. It will start 0, 1, 2, 3, 4, 5, 6, 15. After 15, whatever the value you are going to write, it will store this way. So it will store 0. If you are writing 17, it will store 1. If you are writing 18, it will store 2. If you are writing 19, it will store 3. If you are writing 20, it will store something like that. Okay. And you always remember this point when we will discuss about the characters. If you are writing here, character will take, if you are writing character A, that will only take 1 byte of memory. Means that will only take 8 bits of memory, 8 bits, only 8 bits. And if you are taking 8 bits of memory, then in this case, maximum value can store 255. But when you are storing 256, 257, what value will store? That we will see in the next class. Okay. So next class is very important because we are going to discuss about the 1s complement and 2s complement. And definitely some question will come in your exam related to 1s complement and 2's complement. Okay, so we will see how to find the decimal value of this number, how to find the decimal value of this number. Okay, now you can see if you are going to add this two number using the sign magnitude, what is the answer you will get? Anyone. What is the answer you will get if you are writing 1011 and 1100, and now I assume that this number again sign magnitude number. Okay, what value will get? What value will get? First will tell me if you are going to find 100, what is the decimal value of 100? In the sign number, what is the decimal value of 100? Anyone? 100, what is the decimal value? 100, what is the decimal value? What we can write? 100 minus 3 and 1100. What is the decimal value of 1100? 1100. What is the decimal value of 1100? Minus 4, minus 3 plus minus 4. What value will get? What value will get? Minus 3, minus 7. But when you are using this summation, what value you are getting as the output? Anyone? 7. That is also one disadvantage of using the sign magnitude. Okay, so in the next class, we will see some example related to that. And now you can see this types of question you can get in your exam. Now we'll tell you the smallest integer that can be represented by 6-bit number in 1's complement. That we will see in the next class. But in the case of sign magnitude, what is the answer you will get? The smallest integer that can be represented by 6-bit number in sign magnitude. In sign magnitude, what is the smallest number we can represent? If you are using 6 bits number, what is the smallest number we can represent? Minus 31, not 33. I am writing this one. Don't be confused here. So we are writing this one, not the minus become plus. We are writing this one. So what is the answer? Minus 31 and maximum we can represent 30. Okay, and definitely 5 to 10% question will come from number system in your medicine exam. That's why this is a very important topic, even for the placement exam. Also, this is very important topic. So now you can see if you are going to check here, we have asked 3 plus 3, 6 question. We have asked 6 question in your medicine exam. And this question also, just you can see, 6 plus 1, 7 question, totally related to the number system. Clear?
Yes, sir.
Yeah. So next class is very important. Okay, so don't miss any classes. So next class is very important because we are going to start the 1's complement and so if you have any
Sir?
question, yeah, tell me.
Sir, can you explain that in the beginning of the class you said that ASB to the base 10. Can you explain that again? How will you convert that in decimal system?
Which one?
Sir, the number you wrote A5B base 10.
Okay,
Where you
okay,
said-
okay. Yeah, 5 base. Okay. Just 1 second. Are you talking about the hexadecimal number? Right?
Yes, sir.
So hexadecimal number means just you can see. So as for example, if you are going to write here 75, something like that, 75, and you are going to convert this one to the hexadecimal. Okay, this 10 to the hexadecimal. So how to convert 75 and then we'll divide it by 16. If you are going to divide it by 16, what is the quotient value will get? Just will tell me. What is the quotient value will get? 16 into 4? 64. Okay. So we are getting here remainder as a quotient value as a 4, remainder as 11. 11 we cannot write in the single place. That's why we are writing here B. Okay. 10 means we will write A. 11 means we will write B. 12 means we will write C. 13 means we will write D. 14 means we will write E. And 15 means we will write F. And here basically we are writing the remainder value. So 11 we are getting the remainder, we cannot write. So what is the answer we will get? 4B. Okay. Base 60. What is the value we will find? 0, 1. In place of B, what value will write? 11 into 16 to the power 0 plus 4 into 16 to the power 1. What value will we are getting here? 11 plus 64, that is equal to 75. Clear?
Thank you, sir. Thank you, sir. Yes, sir.
Sir,
Yeah, tell me.
sir, if we use a sign management system, like we won't have many problems in like today's computers, right? Because we use we can store a number in 16 bits, right?
Yeah, no, what I'm saying. So if we are going to store the number, means we have taken the simple example. We have taken the simple example. Okay, if you are working for the means 16 bits, okay, then in this case, whatever the number we are also getting, that is also large number. We are not getting the smaller number. So whatever
Yes,
the program we are writing for the storing the ATM card number, we are storing the balance of the balance account number, something like that. So in this case, the balance is also big number. So we cannot
Yes, sir.
store by using the sign magnitude.
So it will fail for large numbers, right, sir?
Yeah, it will fail for large number, and also there is no confusion. If you are writing +0 -0, you have always confused. Because according to the computer, +0 and -0 both are different. But in the real life, +0 and -0 both are same.
Yes, sir. Sir, and if we can store a number like in 16 bits, it means that it can have only maximum of 16 digits, right, sir? So a computer cannot take
Yes.
numbers with more digits than that.
Yes. So if you are taking 16-bit signed number, unsigned number, what is the maximum value you can store? 2 to the power 16 minus 1.
Minus 1, yes, sir.
After that, you cannot. After that, it will follow the rotational policy.
Yes, sir.
After that, it will follow the rotational policy.
Sir, I have a question.
Yeah.
So, sir, when we were discussing that A is equal to 2.6 and 2.6 equal to A,
Yes.
so when we wrote a float A equal to 2.6, we said that it did not store it like accurately because,
Yes.
sir, but then when you say A is equal to 2.6, that 2.6 which we have written as a float number, how will that be stored in memory?
Yeah. So what I am saying, like, let's just try to understand. The same thing. Today I am asking one question. 1/3. What you can say the answer?
0.33.
0.33. Maybe after 5 days, I am asking the same question to you. You cannot give the same answer. You cannot guarantee you will give the 0.33. You may say like that 0.34 or 0.3333, something like that. But I am giving you a number called 1/2. And today I am asking you 0, you will definitely will say 0.5. And after 10 days, even after 5 years, I am asking you the same question 1/2. Again, you will say the same answer 0.5. Why you are saying the same answer? Because we are getting the exact value. The same like that here also. Okay. So when the system will start execution, I have already mentioned the first your program is present in your second stage. Okay. After that, the system will start execution. When the system will start execution, first it will bring to the RAM. And after that, when you are writing the instruction called int A equal to 2.6. Okay. Now for 2.6, it will store some binary. Okay. It will store some binary value. What is the equivalent binary? Now next time again when it is coming like that, you have to check A equal to 2.6. Again, it will calculate the binary value of 2.6. But the problem is, because we are not getting the exact binary value, it may be happen like that. The second time when they are calculating this value 2.6, it will stop before that. It may be possible. During the run time, again it is calculating the same value 2.6, but we are not getting the exact value. So that's why we get little bit different presentation. Equal means exactly same. There is no any difference. Computer system is equal means there is no any difference in a single point. If you are writing 2.33335010 and after that if you are writing 4, in the computer system if you are writing 2.33 after 15 point if you are writing 4 and second one we are writing 2.33, only both are different number. So that's why it is coming different.
Yes, sir. Sir, and one more question. The same thing I tried in Python shell, but then it gave me true there. So is this?
So that will totally depend upon the compiler to compile. You cannot compare this one with your Python. You cannot compare this one with your Java. Okay, that will totally depend upon the compiler to compiler. What do you mean by that? Just you can see. So some compiler will use some value. So as for example, now you that if you are writing whatever the value you are getting here. Now we do the 3, 5, 6, 7, 8, 9, 10, something like that, whatever the value we are getting here. Now we do that the compiler will only consider the first 5 bits, 2.356 and 2.356. What will happen?
It will evaluate to true.
True, yes. It will totally depend upon the compiler. How many values you are going to compare? How many values you are going to compare? Okay, that will totally, as for example, same like that. If you are writing, if you are going to the supermarket and you are asking to give 10 point, means 10 kg, 0.112 gram of sugar, okay, what they will treat like that?
10 kg.
10 kg. But if you are going to the gold market and you are showing like that, I need one gold 1.11 gram, what they will consider?
1.11.
1 gram. The same like that here also, it will totally depend upon the compiler, means how accurately you are calculating the value. According to the Python, if you are going to write 2.356 and if you are writing 2.35, both are considered as the same number because it will only consider up to 2 decimal. It will not consider apart from 2 decimal.
Yes, sir. Thank you,
That's
sir.
getting the right answer. Yes.
Thank you, sir.
Sir.
Yeah.
Sir, while converting a number into a binary form, after the decimal, we had to multiply it, right? Like 0.5 into 2.
Yes.
And we did that until the cycle repeats again. For
Yes.
an
Or
example.
either you are
Can you
getting
explain
0.
an example like that again?
Yeah. Sorry?
Can you explain that part again? I didn't get it where we have to do it until the cycle repeats.
Okay. So what I'm saying like that. So if you are writing here until you are getting 0 or you are getting the cycle. So if you are writing 2.5, so what we will multiply 0.5 into 2, we are getting 1.0. 0 if you are getting 0. Because 1 we will remove from whatever the value you are getting here, we will remove from here. After that, you are getting 0. So when you are getting 0, we will stop. Second case, if you are writing 0.2 into 2, what value will get? 0.4. You are removing 0, what will get? 0.4 into 2. Again 0.4. Again 0 you are removing 0.8 into 2. 1.6. Again 1 you are removing 0.6 into 2. 1.2. Again 1 you are removing 0.2 into 2. Again you are getting the same thing. If you are going to follow, again you will get the cycle. Again you will get the cycle because again you are getting the same 0.2 into 2, 0.4. 0.4 into 2, 0.8, 0.8 into 2, 1.6, 1.6 into 2, 1.2, 0.2 into 2. So you are getting the cycle. So we will stop there.
Sir?
Yeah.
So in the same thing, can you take an example with 2-3 decimal numbers? As in 2-3 digits in the decimal numbers?
So the same thing. You can take 5.25. Okay. Or 5.625 you can take, or 5.325. So what we can write? 325 into 2. What value will get? Just will tell you. 325, 0.65. Okay. So point
Yes,
is
sir.
coming. So we'll write 0 here. 0.65 into 2. What we are getting here? 1.3. So we'll write 1 here. 0.3 into 2 we are getting what? 0.6. So we'll write 0 here. 0.6 into 2 what we are getting here? 1.2. We'll write 1 here. 0.2 into 2 what we are getting? 0.4. We are write 0 here. Now we'll check like that. So if you are going the long tree, we will stop there. If you are going to long like that, we will stop there. So we'll go through the 5 to 6 time and then we will stop.
Thank you, sir.
Excuse me, sir.
Yeah.
Sir, when you were talking about 1 by 3 not being equal to 1 by 3,
Yes.
In a computer, number is stored to a like for a certain number of bits only, right?
Yes.
And the process to convert a number from decimal to binary would be same, no matter
Yes.
when we do it. So, sir, 1 by 3 at that point should be equal no matter when we compare it, right?
Yes.
So, I'm not able to understand why it is not being
Yeah.
equal at two
Yeah.
different points.
That's why I'm saying. Just you can see the computer is going to follow some procedure to convert this number. It is not like that always they will follow the same types of procedure. I've already given the example. The same. If I'm today I'm asking 1 by 3, what is the value you are seeing? 0.33. Now after 5 years, I'm asking the same value 1 by 3. Can you keep the guarantee like that? It will give the same answer.
Sorry. But that is because I'm not exactly known till where I have to give the answer, right?
Yes.
The computer will still
The
process
computer
the
is
number
also
till the memory is filled or something like that, isn't it?
it is not like that. So sometime when you are going to the last number, okay, computer is using the 32 bits, right? Okay. Now, sometime what will happen like that when you are going to the last number, the computer is only storing 32 bits, means the 20, some bits is used to store the decimal number, and some bits is used to store the only the means what you can say before the decimal number, and some bits are used to store after the decimal, right? After the decimal. Okay. Now, once when you are going to execute the system, okay, when you are going to execute the system, you are writing int a equal to 2.6. Okay, it will go to the ALU, arithmetical and logical unit. Okay, and it will convert. It will find what is the binary representation of 2.6. What is the binary representation of 2.6, and it will store in the system. When it will go to the second time, again it will follow the same procedure. But what will happen like that? The second time when it is going to follow the same procedure, maybe it will not get the same number, exactly same number.
Sir, why is that? Because the
Why?
process is the same. The
Yeah,
amount
process.
of
Yeah,
memory is
process.
same. Then
No,
why?
no. I'm saying the same thing. That will done by the different area. Just you can see if you are talking about your system. System has many core. Okay, that are the 4 different cores in your system. Okay, 4 different. If you are working for the 16, some system has 16 core. Okay, means 16 working unit. You can say like that. 16 different working unit. Okay. Now after that, when you are going for 1 by 3, okay, 1 by 3. So computer will execute this one and they will write 0.33333 something like that. And after that, they have written 0.3 to 0.3. Okay, means it is just like a random. It is written such a way that if you are getting the continuous sequence, lastly you have to eliminate the sequence by using some random number. It is given like this type of instruction. Now, second time, if you are going for 1 by 3, again it will print 0.33333, and the last one it will put some random number. Last one it will put some random number. Why we are putting the random number? Because to stop the number. Now after that, we will not do calculation. After that, we will not do any calculation. So that's why it will stop there.
So this is a process done by the ALU.
Yes.
And the randomness of it is why 1 by 3 would be same the next time will be processed.
Yes.
Okay.
Yes.
Okay, sir. Thank you, sir.
Thank you.